Right, we need to integrate this. We use the substitution u being equivalent to x to the fourth add 4. And this implies that du dx is equal to 4x cubed. Again, we chose this as u because when we differentiate x to the fourth power, we can see that we have 4x cubed. So we have x cubed there. We can actually transpose and just have what x cubed is equivalent to in terms of the new operator du. And let's further to that, we'll just write that as du now. The new operator is 4x cubed dx. All we have to do is divide each side by 4, and we have x cubed dx, which is a substitution here. And we know this is u. So let's go ahead and do that. X cubed x to the 4 squared dx is equivalent to integral, we have a quarter u squared du. Then we have a quarter of a third u cubed at c, which gives us a 12th u being x to the 4th add 4 cubed at the constant of integration. Thanks for watching. I'm Alistair. Right, here we'll use the substitution x squared add 2x add 3. We've chosen this because if we differentiate this quickly by inspection, we have 2x add 2, and we can see a way of actually finding a suitable transposition or substitution for x add 1 dx, and that's what we'll do now. So if we differentiate this, we have du dx is equal to 2x add 2. Now our new operator du is 2x add 2 dx. So if we want to find for x add 1, we just divide both sides by 2. And that's what we'll do here. So we have the integral x add 1 times x squared add 2x add 3 dx. And this is equivalent to a half u raised to the power of a half. And we can write this as integrated to give us a half times two over 3. Now we have the root u cubed. And this can be written in the simplest form as a third root x squared at 2x add 3 cubed here, and the root of cube add the constant of integration. Thanks for watching. I'm Alistair. Right, for this we'll substitute, use substitution u is equivalent to e to the x add 2, which implies that du is equivalent to e to the x dx. And so our integral e to the x e to the x add 2 raised to the 4th power dx is equivalent to what we have. We'll take so u to the 4th, so this is u raised to the 4th power, and e to the x dx, which is du, and this is equal to 1 over 5 u to the 5 add c, which is 1 over 5. Our u is e to the x add 2 raised to the 5th power add c. So key to finding a substitution is to look at what we have here as a power, and also it's easy to differentiate u with respect to x. Thanks for watching. I'm Alistair. Right, so we'll use a substitution here. We'll let u be equivalent to e to the tan x, and this implies that du, we differentiate this and use it as an operator, is sec squared x, and we have e to the tan x dx. Let's make sure you can see this. E to the tan x, we have dx. So our integral can be written as sec square x e to the tan x dx as equivalent to the integral of 1 du. So du is sec squared x e to the tan x dx, which is all of this, and all we have is the constant 1 multiplied by du to give you du. And when we integrate this, we just have u add c, and we know u is e to the tan x, and we add our constant of integration. Thanks for watching. I'm Alistair. Hi. We need to evaluate this, and by doing that, we'll find a definite integral between limits 3 and 2, the upper limit being 3 and the lower limit 2. So first, we'll integrate our integrand. So we have that as equal to 1 over 3 x cubed add x squared minus x. And now we have our boundaries 3 and 2. Now the constant of integration disappears when we evaluate to find a definite integral. Now this is in areas, and so there's no constant of integration. And now we can substitute for our upper boundaries and lower boundaries. We'll use curly brackets. So the upper boundary, we have 3 cube, 3 square. So wherever x is replaced with the upper boundary 3 in this pair of curly brackets. And in this pair of curly brackets, we use for the boundary of 2. So it's 1 over 3, 2 cube, add 2 squared minus 2. Now this evaluates to 45 over 3 minus 14 over 3, which simplified will give us 10 and a third. And there you have it. So we integrate our integrand, we apply our boundaries of 3 between 3 and 2, which will encompass the area. Then we evaluate, substitute and evaluate to get our definite integral, 10 and a third. Thanks for watching. I'm Alistair. Here's our trig expression that we need to find the integral, and we know if we integrate sec square x or ax, then we have 1 over a tan ax. So 1 over a third will give us 3, and this will be tan a third x add c. And next we have tan 3 over 2 x dx. Well, here we have 1 over a, which gives us 2 over 3 ln. We have the modulus of sec 3 over 2 x add c. Thanks for watching. I'm Alistair. Hi, integrate with respect to x. Our numerator is the derivative of the denominator. So this falls into the category of integrals f dash x divided by f of x dx, where we have the answer being ln, or integral being ln the modulus of f of x. We add our constant. So we can write immediately that this is equal to ln the modulus of x squared add 3x add 4 and the constant of integration. So key to integrating any expression is to determine which category it falls into. And there are cases where it's not direct in terms of the derivative of the denominator. In that case, you can actually adjust it. And we'll see another example of that coming up next. I'm Alistair. Thanks for watching. Hi, today's problems are based on trig expressions and how we integrate them. The first statement here is indicating that if we differentiate a function f of x, we have f dash x, but that's only if and only the integral of its derivative is equal to the function at constant k. And here, with a trig, if the cosine of an expression ax add b, and the integral of that, we have 1 over a sine into ax add b at a constant. Let's see how this works. Our first problem is the integral of 3 cosine 4x minus pi over 2 dx. Well, a is 4, the coefficient of x, and we have a factor here of 3, so that gives us 3 over 4 brackets We have sine first. Sine brackets 4x minus pi over 2 and a constant of integration. Here's another. We have the integral of sec square pi over 3 minus 2x dx. Now a in this case is minus 2, so we have 1 over a, which is minus 1 over 2, or minus a half. And we have tan x add k. Please check your standard trig ratios, and check that the derivatives coincide with this statement here. My name is Alistair. Thanks for watching. Right, now we are integrating 1 over x add 1 to determine the definite integral. So if you look at the previous videos, we can immediately see that the denominator we differentiated will have 1, which is in the numerator. So this is in the family of integrals f dash x over f of x dx, and that's evaluated immediately as ln modulus x add 1, and we have the limits 4 to 3, which we write as ln modulus 4 add 1 minus the lower limit, which is ln 3 add 1. Now this evaluates to ln 5 minus ln 4, but we can simplify that and write it using logs as ln modulus 5 over 4. Thanks for watching. I'm Alistair.